Hey guys, welcome back to the shop. We have got a motorcycle wheel in here today that needs a slight modification done to it. This belongs to my buddy Kenny. It goes on his Honda Grom. We did a job for Kenny, I think it was last year. We had a little bracket for his Honda Ruckus where we modified this bracket so that he could accept another little bracket for a tachometer. Anyway, he likes the little small bore bikes, and I know that he's played around with his Honda Grom for quite a while and does customizations to it, puts different parts on it, and this is the wheel that he's been running on the Honda Grom, and it's a super wide wheel. I don't know the specifications to it. I think he told me, but I don't remember what it is, but one of those wide wheel kits. He's got an extended swing arm on it, and he loves to go and ride this bike. He's got some buddies, and they ride out to the beach, and they have a good time. But anyway, he asked me if this wheel is something that I could help him with, and the problem is that I guess because of the width of this wheel, which just using a tape measure, measures about 7 7/8 from face to face there. This side here is the side that the chain, so it's probably mounted like this, and the chain is on this side. But anyway, it's rubbing the face of the wheel here. It's got some rash all over it there where it's kind of chewing into the aluminum. And he asked if I could face about 1/8 of an inch off this side right here. I told him that should not be a problem. Figured we'll just use a lathe to get this done. He said that this flange here that the material needs to come off of, it's not going to be getting into the tire. He says the tire that you're running on this thing is actually stretched out, you know, to lock those beads in there. And so you have material that's still kind of hanging out here that you can visually see even when the tire is mounted on there. So just taking a little bit off this side, he said shouldn't affect it. And so that's what he wanted to give it a try. So he said just take about 1/8 of an inch and we'll see if that works, just to kind of keep the chain from rubbing this side of the wheel right here. So that's what we're going to do. We're going to use the American Pacemaker to get this done, and it's just going to make the job easier. I went ahead and I've got the 4-jaw on the Precision Matthews, and I ran the jaws out, but the diameter of this wheel is just a little bit on the borderline. So this measures 14 1/4 using a tape measure. And once you chuck this in the Precision Matthew with the 4-jaw, it's just out there so far, and it's just going to be way too close on the swing with the jaws extended out holding the wheel there. We have a 16-inch swing, but you got to take in consideration the jaws that you're using to hold the part there as well. So we got the big 4-jaw over on the American Pacemaker. That's going to make the job a lot easier. So we're just going to go over there and use that. So we'll chuck it up in the 4-jaw. Got to get it running nice and true. Set a tool up and just simply face 1/8 of an inch off that. And then we're going to round this corner there as well. And I'll probably just grab the corner rounding end mill like I do for the stuff like this in the lathe, and just put another nice radius right there on that edge and kind of make it look original. So that's the task for the day. We'll go over to the American Pacemaker and get this set up, all right? I've already got my 4-jaw set. Jaw width of 14 1/4. All right. That side looks nice and clean. Now, chucking wheels like this, it's perfectly doable. I've done this many times, but you do have to be careful about how much pressure that you're clamping down on this thing. You don't want to distort it, but you got to have it tight enough that it's going to hold it and not snatch it out of there whenever you're tooling it. But it is going to, usually what happens when you're chucking parts like this and if you're indicating it, you get a little bit of that squeezing where it kind of turns it into an elliptical, so you'll have like highs and lows over on this side, and it's okay. We're not really worried about this side. We want to make sure that it's running concentric, so true to the axis of the machine there, and also this face is not running out like that as well. So we'll have to indicate the run out and indicate this face. Maybe we'll just use this face right in here, because this has all been machined. I know it's been done on a CNC machine. We have no idea how accurate it is and how true it runs, but let's find out, shall we? Let's see. Not too bad right there where it's at. That's pretty darn close, but I can see some face run out. Since it's pretty close on the face, I think I'm going to go ahead and start with the OD just to kind of get it centered up better. So using our dial indicator, I'm going to put it sort of in the middle right here. It's all been tooled, so this should have been, I expected all this was kind of turned at one time. So hopefully it's all kind of running the same. And one thing I forgot, I like wearing my safety glasses, so let me go grab those. That's pretty close. That's within 20 thousandths right there. So I'm going to start with the highs on the dial indicator here and just give it a little extra squeeze and make sure that we're tight. Just small movements at a time. You can see this right here, and it doesn't take much force to turn this screw and move that jaw, because you're technically kind of squeezing the rim more than you're actually moving it around. So that's why you just take small equal movements both when you're loosening and tightening. Low, high, high, low. So I'm going to go back to this high and just give it a little more squeeze, and then we'll go down here our low and kind of give it equal amount of loosening, and then back to the high. It's close, it's under 10 thousandths there. And I don't care what number the needle lands on. I'm watching this needle move, and I just want to make it equal. What we're ultimately wanting to do is wherever that needle lands on that dial face, we want it to be the same from jaw to jaw. So typically when I do stuff like this, I'm going 180 degrees apart. I'm reading these two jaws. Once I kind of get them where I want it, I'll read these two jaws. And we're looking at high and low, and we want to equalize that so that the needle ends up in the same position at every jaw. So like right there, go back, that's about -2 to 3. That one is +1. So you're high. I'm just going to go ahead and give it a little squeeze there. That brought it to 0. And this side over here is -1. It's still kind of moving around a little bit. And I'll get you a better video so you can see what I'm doing here. I want to see how close I am. That one's minus, that one's 0, that one's +1, and that one's -1. So it's pretty close right there where it's at, but we're not done, because we still need to bump it around, which is going to change this readout. But that's pretty close right there where it's at. Let me get you another shot of this so you can see what we're talking about. All right, maybe you guys can see this here. So that right there is -1, go 180, and that's -1. So we got that one right. So we're going to go to this jaw. That's about 0. You got to kind of average it. 0 and 0. So I got it closer before. I should have brought you guys over sooner than that, but we're going to have to do this again. So what we'll do now is just go ahead and move over to the face. I'm going to set this dial indicator up over here. And I think we're just going to set it up on this face here and see how this is going to run. Because really what I want to do is just kind of focus on this little area where we want to make sure this is running nice and true, because this is the area that we're working on. So if it's off a little bit back here, I'm not really too concerned about it, but we still want it to run concentric. All right, there you go. You can see you got high and low. So this needs to go that way. or this side needs to come out. But what we'll do is bump it, because I can see that it's already pulled, the rim face on this side is actually pulled away from those faces of the jaws there. So let me get my soft blow, we'll see. Let me get myself a little extra room here too. Give me a little more room to work here. So that's our high and that's our low. We're going to start with this high here. All right, about even with the jaw, so it's around 31. 31, look at that. Those two are even. This one, that looks like 37 and about 14. Went too far, that's okay. Tap the high side. All right, so let's say 27, 27. All right, let's go back to this one. 30, 33. Didn't do anything there. Few thousandths out still right there. 34, 32, so a couple thousandths still to go on that one. Doesn't really feel like I'm moving it now. And it's really easy to go too far. So that, like, we'll hit it a little bit harder, and sometimes you'll take it too far. That's pretty close. Let's go back to these two. That is pretty close. That's within a couple of thousandths on the face run out right there. So I'm going to bring it back around here to this side. And I'm going to put this right here where this tire seats on the inside or the outside diameter of the rim. And let's see what kind of run out we're getting here on this side of the flange. I think you guys can see that. Let's just call that 20. Yep. All right, so we've got some indicating to go again. This is your high, small movements. Move that joystick over. Low, high. We'll loosen this low just a little bit. Low and high. Yeah, that one was a little bit loose. Loosen the low, tighten the high. So it's around 12, 14, 12. I'm just staring at where that needle is running back and forth, and I'm just trying to equalize it side to side. Pretty close. We're going to move back to the other two. All right, 12, 14. All right, that's 13, 13. And the needle's constantly moving, so you just got to kind of pick a number and run with it. 12, 13. Those are pretty close right there. That's within a couple of thousandths on our OD run out. I'm going to go ahead and bring it back to this face and see if it moved and if we're going to have to bump it again. Line up on a jaw. Let's just call that 25, and that's 30. So it moved a little bit again. Not wanting to move now. I think it's pretty well, I think what's going on this radius of the flange is kind of settled up in those serrations of the jaws there, and it's really not wanting to slide, move past that serration that it's starting to dig into. But we'll see if we can force it. There's a couple of thousandths. Let's check these here. Yep. All right, those two are good. Let's go back to these two. It's 25, 27. I think we may just let that one run right where it's at. Like I said, it's really hard to get it perfect. We just want to get it as close as we can. I'm going to go back to the OD and go ahead and true it up just a little bit more. Tightening the highs because it's only a few thou. That's pretty good right there. Let's leave it alone for a minute and fire up the lathe and see what it looks like spinning. That looks good to me. It looks nice and true. Now, if you're hearing that little sort of tapping sound that the wheel is making, that's the spacer that's inside the bore that spaces the ball bearings out. So it's just going to be moving around inside that bore there. As far as what we're trying to do, it looks pretty good. You can see the OD looks like it's running nice and true. And we come out here to the face, so it looks pretty good too. Now you can see it moving around inside that machine finish there. And I think what that is distortion from whenever this was manufactured. But we've got it where we need it for what we're going to be doing right there. It looks pretty good. All right, so I got to gather up some tooling that we need, and I'm going to get that taken care of, and I'll bring you back. We'll start doing some facing. I had to turn the compound in line with the ways there so that it could bring the tool out a little bit further. So we're going to run our Walter stick tool today. And we have a Walter carbide insert that's designed for cutting aluminum. It's a nice sharp insert there, so it should work really well for this. That should give us plenty of room right there. And a lot of times this cast aluminum, that's what I'm assuming this is cast. Doesn't usually machine all that well, but we'll see what it'll do. We're going to touch off our tool in the face and get a 0 established. I think we'll call that our 0. We've got this mag back indicator here. A lot of people ask me about this. This is from Edge Technologies. It's got some magnets, and this one's designed perfectly to stick right here on the ways, and you can use this to control your movement on the carriage. So we're going to set this one to a 0. That'll be our start point. Let's just take a light cut. Let's see what it does. I've got our feed set at 10 thousandths per rev, I think. Nope, I'm sorry. That one's set at 5 thousandths per rev. This is 20 thousandths. Let's just see what it does here. So we've got 125 thousandths that we're going to take off. I think that worked well. All right, Kenny, it's cleaned up, man. Is that good enough? No, we got a little bit more. We got 105 more we're going to take off. That was our 1/8 of an inch, so we don't need to take any more off the face there. So what we'll do from here is, I think we're just gonna do a chamfer on this inside, that edge there. It's rolled over pretty rough. I think we'll just stick the tool in there at an angle and just break that off like at a 45. That looks pretty good to me, about at a 45. I think we got that edge nice. Let me grab a rag actually. What I want to do is just make sure that we've got all of the burr off of that inside. I feel a little bit there. I think we need to go a little bit more. Right there, there's still a little bit rolled in there. So we need to touch that chamfer one more time. All right, it's trying to chatter on us. I'm just going to slow it down. That was one of those where you gotta get in and out really fast with your tool. Let the tool cut it, but get off of it, because the longer you rub that face, it's gonna just chatter. Problem is, this isn't running as true as we want it to. We've got it trued up, but this was not machined all concentric, so you've got more of a heavy chamfer there. and then a light chamfer right there because it's running out a little bit, just this feature. But we've got it chamfered, we've got all that sharp edge broken off of there, so we're just going to leave that where it's at. And we'll move out here to this outer corner. And I found a tool that I think we'll use. We'll try this corner rounding end mill since that's a perfect ground radius, and we'll see if we can get it set up here so that we can cut this outside corner using that. There's our tool set up in the tool block. I've got it clamped down on a V block. Now I do have another holder that's got a big tool for a ER40 collet that I could use to hold that shank, but the problem is that I'm out here so far, the collet chuck sticks out too far. I wouldn't have been able to get the tool back where I wanted to in this orientation, so the simplest way was just to clamp it down to a V block and go from there. But that's going to work just fine. We bring that up there to that rim, that corner, and that's going to help us get the job done. Stop it there and set a 0 on our carriage. And we'll feed it in. Starting to get a little bit of buildup on there. We're probably going to have to use some cutting oil to help eliminate that chip welding there. Put a little bit of this Tap Magic for aluminum on there and see if that'll help. Good. Well, our corner rounding end mill worked perfect for that. We've got a good looking radius on the corner of the rim. Now, I think we're finished up. As far as the machining, I think we're done here. Okay, we took an 1/8 inch off the face, or 3 millimeters, broke that inside corner with a chamfer, machined a 1/8 radius on the OD there, and I think that's giving Kenny what he asked for. So I'm gonna call this job done. Just get it out of the lathe. All right, well, I'm happy with the job, and I'm hoping that Kenny's gonna be happy with it too. I'm sure that he will. It looks uniform. We've got some nice finishes on there, and it turned out nice. So hopefully with the removal of the 1/8 on this face right here, maybe that'll help eliminate the chain rubbing that face there and gouging into it, and hopefully eliminate some noise that I'm sure it's making there too. But even if it still touches it, hopefully it'll be minimal at that point. It's not going to be gouging into it like it was doing. So this was a nice little job to do today. We got to put the American Pacemaker to work, used a couple of our Walter tools, corner rounding end mill to put the radius on there, and the job was done. So that's it. Hope you guys enjoyed watching this project, and come on back. We've got plenty more to do around here, all right? We'll see you later.